Hello everyone, my name is Dakota Mavras, and I'll be going over problem number 3. Problem number 3 says, an airplane travels at a speed of 80 kilometers an hour. The wind speed is 60 kilometers an hour. What is the ground speed under the following circumstances? Must explain all three. We're going to be using it when the wind is headwind, tailwind, and crosswind. Basically, headwind is going against the airplane, tailwind is going with the airplane, and crosswind is going perpendicular to the airplane. Okay, so now let's get started. I worked out this, and I will explain it for the headwind. So, like I mentioned, headwind goes against the airplane. So it said that the airplane was traveling at 80 kilometers an hour. So I wrote it out. Then the headwind was going at 60 kilometers an hour. So here you can see the two vectors are going in opposite directions. Since the vectors are going in opposite directions, in order to get the net force, you must subtract it. So you take the 80 kilometers an hour, subtract it by 60 kilometers an hour, and you'll get an overall net force of 20 kilometers an hour. Since 80 is greater than 60, the overall direction will be going this way with the airplane. So this 20 kilometers an hour is going this way, the direction with the airplane, since 80 is greater than 60. Okay, now I'll work out tailwind. So, like we mentioned, the airplane was going at 80 kilometers an hour this way. Tailwind goes with the airplane. So tailwind is going 60 kilometers an hour. Here you can see both vectors are going in the same direction. Since they're going in the same direction, you get the overall net force, or I should say net velocity. Yeah, this is more like net velocity, or net speed. Net velocity. Sorry, not net force, net velocity. Okay, to get the overall net velocity, since both vectors are going in the same direction, you add it. So we take the 80 kilometers an hour of the airplane with the 60 kilometers an hour of the tailwind. You add those two and you get an overall net velocity of 140 kilometers an hour. Okay, so I'll explain it again. Tailwind goes with the airplane, so it goes this way with the airplane. Since both vectors are going in the same direction, as you can see, you must add it to get the overall net velocity of the airplane. So you add 80 and 60 kilometers an hour, and you get 140 kilometers an hour. Okay, so that was using the net velocity with vectors. So we added the vectors to get a net velocity of the airplane. Now we're going to be using the parallelogram rule, also known as the 3-4-5 rule for the crosswind. So, yet again, the airplane is still going at 80 kilometers an hour this way. However, we have crosswind now going perpendicular to the airplane at 60 kilometers an hour. Using the parallelogram rule, or the 3-4-5 rule, I should say, it's a squared, which would be this or that, it doesn't matter, plus b squared, either one yet again, equals c squared. C squared is the resultant, which is this. That will be the resultant in the overall ground speed of the airplane. So now let's substitute in our variables. So we'll have 80 kilometers an hour squared plus 60 kilometers an hour squared equals c squared. Okay, so I put this into my calculator, and 80 kilometers squared gives us 6,400 kilometers an hour, and 60 kilometers an hour squared equals 3,600 kilometers an hour. Okay, and we're still solving for c squared. So if you add 6,400 and 3,600, you add them up and you get 10,000 kilometers an hour. And that still equals c squared. So all we did was add that up and bring it down. Still get c squared. You're solving for c, which will be the resultant up here. So now to get rid of the square, you square root it, and what you do to one side, you must do to the other. So we're going to square root 10,000, and that will give us 100 kilometers an hour equals c, because the square and the square root cancel. Square root of 10,000 is 100. So we'll get a final answer of 100 kilometers an hour. And the c is the resultant. That's all this is. This, the overall direction of the crosswind, is the resultant, which is c. Okay? So 100 kilometers an hour will be the final resultant in ground speed of this airplane. There's headwind going in opposite directions, so you subtract. Tailwind going with it, so you add. And crosswind going perpendicular, so you use the 3-4-5 rule or the parallelogram rule. And it should work out to be 100 kilometers an hour as the resultant right here. Okay, I hope it made sense, and I hope everyone enjoys their time in this class. Thank you.